with the three terms, here's basically what we got. We're going to start with the easy part first, and we'll build up to the harder parts as we go through these. And again, what we're looking at is that we're still looking at, if it's three terms, we're talking about a quadratic equation that, again, we're going to kind of type into some graphs and some solutions a little bit later on. But the main thing you have to do is you've got to have the terms in descending order. And if it's ax squared plus bx plus c, we're looking at it so that over here in this case, the first term, your a value, is equal to 1. Okay, and then basically here's what we're going to do. When we've got this situation, we're going to find the factors of the c term whose sum is equal to the b term. And we're not going to do anything with the a value because it's 1. And again, because the first term is 1, it's a shortcut, and it makes things go a little bit quicker, a little bit faster, and it kind of go through some stuff. All right, so here's the first example we'll do. And hopefully this will come back to y'all because I think at some point in time y'all should have done this. But if you haven't, then, well, we'll get you caught up. So, all right, so let's say we're doing x squared plus 7x plus 12. Okay, so if we go through this one, our a value is 1, our b value is 7, and our c value is 12, just like we were doing yesterday if we were going to graph this thing. So this would be one of those things where yesterday we could have graphed this one, and basically what we're going to do today is we're going to say, all right, if we graph this equation, we know exactly where the x-intercepts would be for this thing if we had to get those parts of it. So we're going to look for the factors of 12, and we need to pair where the sum is going to equal positive 7. So it's the factors of the c term whose sum is going to equal the b term. Okay, and probably one good thing to do is to go ahead and put the sign. I know these are all positive, which makes it a little bit easier, and we'll look at some of the negatives in a minute. But if all the terms are positives, it makes it a lot easier because all the factors of 12. We start with 1 and 12. We've got 2 and 6, or we've got 3 and 4. All right, and the only way to get 7, it's got to be 3 and 4, right? And now, again, this is a shortcut we'll do. We'll actually do the longer parts of it later, but the shortcut is, as long as this first term is 1, then we're going to break this thing off, and whatever these two factors are, we're going to put the variable here first. This would have been a positive 3 and a positive 4, because if they're all positive here, they all have to be positive here. All right, here's some, I remember this, so okay. So then we get x plus 3 and x plus 4. All right, is that ringing some bells? Starting to look familiar? Okay. Been a little while. And again, you may have done a little bit of factoring in geometry, just a maybe tiny little bit. So this is more going back to the algebra 1 stuff. Again, depending on where you were with COVID and when it hit, who knows how much you got out of it. So. All right, so for number 2, let's go with x squared plus 19x plus 60. All right, so a is 1, b is 19, c is 60. So again, we're going to look for the factors of 60. And that was a positive 60, and we want the sum to equal positive 19. All right, so we go 1 and 60. Could be 2 and 30. Could be 3 and 20. Let's see what could be. I'm going to put these over here. Could be 4 and 15. Could be 5 and 12. Could be 6 and 10. Again, right now everything is good because as long as all the numbers are positive, we don't really have to worry about the signs on these. So finding the pair that will add up to be 19. 4 plus 15 is 19, so it's going to be 4 and 15. Now, some people ask, if we go through the list, if we find those numbers, do we have to go ahead and list the other ones? No, because it's just thinking about all the possible numbers. So, if this number had been 61 in the middle, if you do 1 and 60, well, then you could stop there because, you'd have 1 and 60 that add up to 61. you'd be good to go. So final answer here would be x plus 4 and x plus 15. Okay. And sometimes people ask, does it matter which number goes first? No. Whether you put x plus 15 first or x plus 4, it doesn't matter. As long as you got an x plus 4 and x plus 15, it doesn't really matter, where they go and what they do with it. All right, now here's where you have to kind of be careful. And going back to some ways that they did this back when I was growing up, we're going to kind of do it a little bit different from what it was back then. So that when you have positives and negative numbers mixed in, that let's say we're doing x squared plus 2x minus 24. That if you throw a negative into that equation somewhere, here's what it comes down to. You're still going to go ahead and list off the factors of negative 24, where the sum would equal positive 2. But here's where you get to take all the guesswork out of this thing. The sign of the B term, which in this case is this positive 2, that sign will always go with the bigger factor every single time from now until eternity. Always, every single time. And there is no if the B term is this and the C term is that. No. Whatever the sign of the B term is, that will always go with the bigger factor every single time. So if we do our first factor, if it's 1 and 24, 24 is the bigger number. So that means that this has to have a plus with the 24. Okay, to find the other sign of the other factor, you basically just divide this negative 24 by this positive 24, which would be 1. But if you divide a negative and a positive, that means this one would have to be a negative. And that will work every single time. Every time. No matter what you do, it will always kind of be that way. So if we list the next factors, which is 2 and 12. 12 is a bigger number. It's going to have to be positive. The smaller number is going to have to be negative. So if we go through the next numbers. Again, right now, none of those add up to 2. So we've got 3 and 8. Again, B term goes to the bigger number. The other number is going to be negative. And then the last one, if we go 4 and 6, sign always that positive will always go with the bigger number. That one will go there. And finally, the pair that adds up to 2 is going to be the 4 and the 6. And again, the 4 has to be negative, and the 6 has to be positive. And again, which one you put first doesn't matter, but you've got to have an x plus 6 and an x minus 4. Which one's first doesn't matter. All right, everybody, so good so far? All right, let's do this. Let's give you one where it's x squared. Let's go minus 3x minus 40. Okay, so our A is 1, our B is negative 3, our C is negative 40. So again, we're going to go factors of negative 40. And the sum has got to equal, in this case, a negative 3. Okay, and I always tell people, use the 1 in the number just to kind of get the signs correct, because usually it's a lot easier from there. So if we go 1 and 40, again, before you do anything else, get the signs correct. If you can get the signs correct, everything else is usually pretty easy after that. The B term is negative 3, which means that negative always goes with the bigger number. So that's going to put a negative there. And what happens when you divide a negative by a negative? That makes the other number out to be a positive. There you go. So basically what we're doing is, if we know that this number, if we know that this is 40, and that's negative, if you divide those two numbers like a fraction, then that means this thing will simplify down to a positive 1, and that's kind of what we're doing in that case, to kind of make sure that we get all the signs correct. All right, so if we do 2 and 20, we know that the bigger number is going to be negative, the small number is going to be positive. And I kind of like to stay in that pattern of I always put the bigger numbers on one side and smaller numbers on the other side, and that way the signs are always kind of matching up. It seems like there should be a lot more than these options if we go 4 and 10, but there's really only one other option. And then there, usually it's pretty easy. Which one's going to add to -3? It's got to be the last one, right? It's got to be the 5 and the 8. So then we're going to have x plus 5 and then x minus 8. Okay, so sliding over for this one, for the three terms. Now here's the big thing for this one is, if we're doing x squared plus bx plus c, and the first term is not 1, we're going to add an extra step in the beginning and an extra step at the end of it. That we're still doing this thing in the middle. We're still going to find the factors whose sum equals the b term. We're going to write out the parentheses, but we've got to do an extra step here, and then we got an extra step here at the end of it. So it's one more thing that's in here. And the thing is, this is the easier way. There's harder ways to do this thing. So this to me is like the easy way. This is just a super shortcut if the first term is 1. So it's an extra shortcut for these. This is kind of like the standard way you have to do stuff. Okay, so now we're going to call this, some people call it AC method. We kind of call it bottoms up here at Sparkman. If you know the song and you want to sing it, go ahead, but I'm not going to sing it for you. Basically, here's what you're going to do. You're going to multiply the A and the C terms together. Okay, so we're going to do A times C. And then once you get this number, you're going to find the factors of that number that equals the B term. So that's part where it's going to be the same. You're going to write out the parentheses just like we did before. But here's that extra step at the end. Because we're going to multiply by A in the beginning, the numbers are too big because we've multiplied two numbers together. So to make it even its way back out, we're going to go back and divide both of the factors by the A term. Which means then you've got some fractions you're probably going to have to simplify. 50-50, usually what it comes out to. One will, one won't a lot of times. And then here's the bottoms up part. Then to make this thing work out, we're going to do the bottoms up part of it to kind of pull it back up here. And where you pull the bottom number, your denominator, back up in front of the x, and that's the bottoms up part that we're going to do for this thing. All right, so we're going to get 1 on here because there's probably about the only room to get 1 on here. We'll have to go to like a separate sheet of paper to get some of the other ones. But here we go. All right, so we're going to go 2x squared plus 11x plus 12. So we're going to start with the first one, all positive numbers, just to make things a little bit easier. Okay, so our A is 2, our B is 11, and our C is 12. And so for this one, the very first thing we're going to do, and again, the very first term here is a 2, and we'll show you one a little bit later on where we have some greatest common factors for this part. But here's kind of what we have to do. We're going to do 2 times 12 to make that 24. So if we do 8 times C, that's 24. And we're going to find the factors of 24 where the sum is going to equal 11. And again, these are all positive, so makes it a little bit easier there. So just multiply your A and C in together, and then we're going to list off the factors. So now we're back to doing the same thing. We're going to find the factors of 24 that equal 11. All right. So 1 and 24 could be 2 and 12, could be 3 and 8. And you go, oh, there we go. So we got 3 and 8. That'll get us to 11. So then we write out of parentheses. Okay. Now, and most people that miss this problem, they miss it right here because they get there and they go, oh, I've got my 2 numbers and I've got parentheses and I'm good to go. But if you look at the last number, if we went back and did the full method, which we know we've kind of sort of been doing that a little bit, because basically factoring is just reverse full method. Full method is reverse factoring, that they're just opposites of each other. If we went back and multiplied this together, we'd have 3 times 8, which means that last number would be 24. We need the last number to be 12. So that's where we've got to go back and divide everything by A, because we multiply by 2, everything is twice as big as it should be. So now we got to go back and divide everything by 2 to even this thing back out. Okay, and then we're going to simplify the fractions we have. Nothing you can do with 3 over 2, so it'll stay like that for just a second. But you've got 8 divided by 2. That's pretty easy. That's 4, right? Okay, and then here's where we do the bottoms up. This, because we don't like fractions, right? Everybody's pretty much in agreement. We don't like fractions. So we're going to take this denominator, this bottom number we've got here, and we're going to pull it up in front of the x and make it 2x plus 3. And now we've got the x plus 4. Okay. And again, if we did our full method, we'd have 2x times x, which would be 2x squared. If we did it back here, we would only have x times x, and that would have just been x squared. The 2 is missing, so this is just kind of doing that placement of stuff that's here. Now, here's the thing with this one is, depending on the teachers that y'all had leading up to this one, if there were 4 different teachers, they probably taught this 4 different ways, roughly. Some people had you do factor by grouping. Some people did this, but they did a little tweak on it. So, there's all kinds of different ways to do this one. And again, this is something that I teach this different now than I did when I was teaching it at Spartan Middle when we came up with this idea like 15 years ago, because we found this thing, the bottoms up method, that was a little bit easier than what we were doing then. So every time we try to find something, it gets a little bit easier as we go through these. All right, now here's what we do. I don't have room to do this on this paper just because we ran out of room. So if you want to get just a separate piece of paper, or if you've written it small enough that you can get that in, you can do that. But we're going to do a few other questions. Doing this on a separate sheet of paper just because I don't have room to get that on here. So if y'all want to transition to that, or if you've got room or whatever you need there, we'll kind of go for this one. So still sticking with this same thing when a doesn't equal 1. Okay, so one more positive number. Let's do 2x squared plus 11x plus 15. And then we'll throw in some negatives just to see how it feels with the negatives in there. All right, and again, very first step is, because the first number is not, again, if it was just x squared, we would just look for the factors of 15 that would equal 11. But because of the 2 in front, now we're going to multiply 2 times 15. So that's the factors of positive 30. And we want the sum to equal positive 11. Again, they're all positive, makes the work a little bit easier. So if we start checking it, we've got 1 and 30. We've got 2 and 15. We've got 3 and 10. Finally, we get 5 and 6. So that adds up to 11. That's 5 and 6. So that's x plus 5 and x plus 6. And again, if you just sometimes if you just stop and look at the numbers, the first number has got to be, if we went back and did the full method, we'd have x times x, which would be x squared. It's got to be 2x squared. So that's already telling us something's a little off here. If you did 5 times 6, that would be 30. The last number's got to be 15. So again, it's too big. So because we multiplied by 2 in the beginning, we got to go back and divide everything by 2, because this number's got to be 15, and right now it's sitting at 30. All right, so we've got the x plus 5 over 2, which won't simplify. 6 divided by 2 is 3. That will simplify. And any fractions that's left over, we said we're going to do the bottoms up on this one. So we're going to take this 2 that's at the bottom, pull it up in front of x to make it 2x plus 5, and then x plus 3. And in just a little bit, I'll show you a way that some teachers may have taught this doing something else. And if you do that and you want to go that route with it, then I'm fine with it. Now, here's the thing, too. Just because we do it this way, if you've got a different way that you've done this in the past and we go through something, you go, oh, I remember doing that, and you're fine with that, you don't have to do it my way. This is just a way to do it. So if you want to do something different, then by all means, feel free to do that. This is just something I feel like is like the best option that we have based on everything that we put together for this All right, here we go. We got some negatives. So let's throw negatives at you because that's where we always kind of, you know, sometimes we hit the brakes a little bit. We're good with the positives, and we get to negatives, and everybody goes, whoa, whoa, whoa. No, 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 no. We don't like that. So. All right, so very first thing, again, we're going to do the A times the C. So that's 12 times negative 3. That is negative 36. So we need the factors of negative 36, where the sum is going to equal negative 5. All right. Now, again, here's where we go back to that sheet that we had. That this is where the plus minus sign comes in if you've got positive and negatives. So we're back to the same thing. The sign of the B term will always go with the biggest factor. So in this case, if we do 1 and 36, it's a negative 5. So the B term has to be negative. And if you divide a negative and a negative, it makes the other number a positive. So every time we do this, if we write down two factors, the bigger factor will be negative, the smaller factor will be a positive. Now, and I know some math snobs out there will say, well, if you do this, 1 and 36, 36 is not the bigger number. 1's the bigger number because it's positive. Yes, it is. But if you just write down two numbers, if we write down 2 and 18 with no signs, guess which one's the bigger number? 18. And that's the way we're going to do this. So if we go through this route, and again, I know it may not be the snob math way of saying this one, but it works, and it works every single time, so you don't have to worry about anything else. So the 18 will be negative, the 2 will be positive. That didn't work. So if we go 3 and 12, that's not going to work. If we go 4 and 9, I heard some people talking earlier. They were like, "Yeah, it's going to be 4 and 9." So now we've got our factors. So we know it's going to be 4 and 9. Okay, so we've got x plus 4 and x minus 9. But again, if you look at it, you can tell, all right, that's 4 times 9. That's 36 at the end. This number's got to be 3 because we multiply by 12. That number is way too big. So to even it back out, we're going to go back and divide both numbers by 12. All right, now we've got two fractions, and we're going to simplify. 4/12 is going to be 1/3. 9/12 would be 3/4. Okay. Everybody all right with our simplifying there? Because 4/12, we can divide them both by 4. 9/12, we can divide them both by 3. And so now we've got two fractions. We've simplified it down as much as we possibly can. And now we got to do bottoms up on both of them. So we're going to pull the 3 up in front of the x here to make it 3x plus 1. We're going to pull the 4 up in front of the x to make it 4x minus 3. And that's what we're looking for right there. Okay. And again, just from years past of doing this one, most of the time, everybody's good doing this part. They'll do 3 times the negative 3 times 12. They get all the factors. They'll get here, and then sometimes people get happy and they'll stop because like, oh, I've got my number, so we're good to go. That's the big step that you got to have right there. That you, if again, because we're multiplying by 12 here, you've got to then go back and after you find your factors, you got to divide it by 12 to even the things back out. And I'm not going to put this on the video, so I'm going to pause it right here. Okay, so we're going to do the 4 terms because some of y'all might have actually factored these problems doing it this way. And if you see this one, you might kind of look at it and go, oh, I remember this thing. So maybe this is where it came in. Maybe not. So this might look familiar. But if you have 4 terms, it's factor by grouping. Here's what we're going to do. Because what may have happened back then, and we can kind of show it to you this way, is they may have had you kind of do these things back then and do factor by grouping, possibly, with this one. But here's what it would look like. So if we've got 4 terms, let's go with, let's see. Oh, let's go with, wait, I got my number for a second. I take a breather. I think we can squeeze 2 of these in. Let's go 2x to the third plus 3x squared plus 8x plus 12. Okay, so what we're going to do is we're going to put parentheses around the first two terms. And we're going to group them together. So it's going to be 2x to the third plus 3x squared. All right, we're also going to put parentheses around the last two terms. And no matter what you do, and again, I still take the sign in there with it, no matter what you do, you always go back and put a plus in between those two parentheses. Like, what about the plus that was here? Well, technically, that's a plus 8, so we want to take that sign with this one. Sometimes it's overkill, sometimes it's not, but, we'll just kind of see. All right, so then we're going to factor out the greatest common factor for the two terms. So if we've got 2x to the third and 3x squared, the only thing they have in common is the x. And remember, if you're doing greatest common factors, you take out the smallest amount of x's they have. So if you got x to the third and x to the second, we're going to take out an x squared. So that'll leave us with a 2x and then a plus 3. Okay. Take the greatest common factor out of the last one. 8 and 12, you can divide them both by 2. But again, you can even go a little bigger. You can divide them both by 4. So if we take out a 4, that would also leave us with 2x plus 3. Okay. Now, and the good thing about 4 terms with factor by grouping is it has a built-in check on it. If you do these two things, if this parentheses here and this parentheses here, if those aren't the same, you know you did something wrong. You either took out a negative when you shouldn't, you didn't take out a big enough factor, or you just factored it wrong altogether. So these two things have to be the same. If they're not, you did something wrong. You need to go back and check your work. So it's got a built-in check on it. Once that's the same, here's basically what we're going to do. We're going to take whatever you've got out front, the x squared and the 4, those are going to go in one parentheses together. And then whatever this common parentheses was that was here, it's just going to follow back behind it so it's there. Okay. And some people actually taught the factoring we were doing back here with the bottoms up method. Some people actually taught it with doing factor by grouping with the 4 terms. And I'll show you how they did that in a minute. And if that was one of you that did it this way, I'll flash back in a minute, kind of show you that one. So let's get one more of these in. So let's go example 2. Let's go with 12x to the third minus 3x squared minus 8x plus 12. That basically, we're going to take the exact same problem we had before. Wait, make that a 2. Oops, my bad. And we're going to tweak it just a little bit. We're going to tweak the numbers just to kind of change some stuff up a bit. All right, so when you group these together, again, go ahead and group the first 2 terms together. Group your last 2 terms together. And then always put a plus sign in between the 2 parentheses. Because if you don't, it's multiplication, which kind of changes the gears on this thing a little bit. So even if there's a negative, so I always tell people, you always go back and put a plus sign between the 2 groups when you do factor by grouping. Even if there's a negative there in the middle, that negative goes with the 8. So we can still rewrite minus 8x as plus negative 8x, and it will still be okay. We didn't really need it back here because it's already positive and it was overkill, but that's fine because it's just, that extra part of it. All right, so if it's 12 and 3, you can divide them both by 3. You've got x to the third and x squared, so we can take out an x squared. And if we do 12 divided by 3, that is 4. We took out 2 of the x's. That's 1 x that's left over. 3 divided by 3 is 1. We took out the x squared, so there's nothing left there. Okay, and I'm going to do this in pencil because we're going to go back and erase this because I'm going to do it wrong to show you a what if here. I find a pencil. There we go. All right, so let's say we're doing this one. If we got 8 and 2, let's say you take out a 2. And then we're going to be left with negative 4x plus 1. Okay, I realize that's hard to see, but that's fine because we're going to erase this. All right, so if you get here and you look at this and you go, okay, well, these aren't exactly the same. I've got the right numbers, but the signs don't really match up. So what that means is back here, instead of pulling out a positive 2, we should have pulled out a negative 2 because these signs have to match up. exactly. Everything, all the numbers, everything has got to be exactly the same. So if we do a negative divided by negative, that would make that a positive 4x, which is what this one was back here. So that's got to be a positive 4. And then 2 divided by negative 2 would make that a negative 1. Okay, so that's the good thing about factor by grouping with 4 terms. If these things aren't the same, you know you did something wrong because they have to be the same to make this thing work. Okay, so then pulling it all together, that would make it 3x squared minus 2. And then that 4x minus 1 is just going to fall back in behind it there. Okay. And again, the factoring is just reverse full method. If we did the full method here, well, these would be the F and the O and the I and the L if we did the full method with this thing to get us back to here. But that would be our final answer that we're looking at for there. All right, so what we're going to do, we're going to wait. Well, yeah, we can wait. We're going to do the 2 terms tomorrow because it's a little bit something different because I want to go back and do some other reviewing tomorrow before we do that. So we'll kind of wait and fill in the other part of it there, and we'll do some more factoring tomorrow before we kind of finish this thing out. If you're keeping up with notes, I think this is number 15. Yeah. So somewhere back here, if you need to put number 15, on your notes, what we're going through, you can do that.